Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama-Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
We're here today at Panama Elementary School, home of the Yellow Jackets, and today we're all here to... Thanks a lot. We're here at Panama School today with a group of fourth graders as part of the ACES program. They're living in the world of division. 2 digits, 3 digits, sometimes even 4 digits, divided by 1. We've had a conversation about the different methods and models they've used to divide, long division, partial product. And so we decided today to put them to a little bit of the test with reasoning and with some other choices that they may not be ready for. So today we're starting things off with an open middle problem. Come on, check it out here. On the board, you may notice we have 3 boxes, a division symbol, and another single box. Their task is to create a division sentence with the largest quotient possible. Now, that's a pretty straightforward task for reasons I'm sure that you can envision when you think about the friendliest types of division. So, when we see that groups are starting to pick this up, we're going to flip the script a little bit. So let's kind of see where they stand here with the numbers that they've chosen. So we see a group here that has decided to take the largest numbers and create a division sentence using solely larger digits. Now there's some that are utilizing the area model to divide as well as long division, but they're going with very large numbers in the hopes that that comes up with a larger quotient. Let's check out another group over here. And I think they came to a realization very quickly. So talk to us a little bit about your strategy here to find the largest quotient, because you came up with 987, and that is pretty big. So how did you figure that out?
Since you said that we can't use the numbers twice, we just thought of the highest numbers times 1 to equal the highest number.
So you found the largest value to start off with that you could create without repeating a digit. Mm-hmm. So that's 987. And then realizing that any number divided by 1 is itself, you realize that that is going to be the largest quotient possible. We're going to come back to this group in a moment and flip the script a little bit. But let's go back here and see where we stand as we continue forward here. So we see some very similar connections here with dividing 987 by 1. Well, yeah, of course, when you take your largest values and then divide it by 1, you're going to end up with right back where you started. So we have another group that came up with the largest quotient possible. Let's revisit this group one more time before we throw things a little bit upside down here. Okay. So, what was your thinking with going with 987 divided by 6?
The larger it was, then the higher.
So, if you divide a larger number, does it matter what you're dividing it by to get a larger number? Because 987 is the largest 3-digit value you can make. What would happen if you divided this by a smaller value?
I think we might still get a bigger number.
You think the number would get bigger as you get smaller values? Okay. So then what do you think would happen if you divided it by 1?
We would just get the same answer.
Which would be pretty big, right? Mm-hmm. Almost as big as what you started with. So we all kind of came to the realization that the largest values possible divided by 1 would end up with the largest quotient possible, 987 divided by 1. Now, we gave a little bit of a prize to the group that came up with the largest and ended up with a 3-way tie. So I'm going to go ahead and throw a little bit of a challenge here. This is going to be the tiebreaker, okay? same idea. Now, your task is to come up with the 3 digits and the 1 digit, same rules. You can only use a single digit once, but now you need to come up with the smallest quotient possible. There are some squeeze happening here, and some ideas, some sparks flying. Smallest quotient possible, open middle. Go for it. Some interesting connections being made with some of these groups as they have a conversation. If we have a large quotient, if we have a large divisor and a small dividend, we're going to get a large quotient. So then what are the tools that are going to allow us to have a smaller quotient? What do we need to do with our divisor and dividends and the values that we use to build this? We're going to let these teams play around with this a little bit, because there's a really rich conversation happening across this room with all 3 of our groups. Some might argue it's a math debate, others might classify it as a fight. All I know is that it is lively. We're gonna let this happen, we're gonna let it breathe. When we come back, we'll get into some of the products of these conversations and see where they've taken this journey as the path to the prize grows at Panama. Back here at Panama, and the conversation has not stopped one moment until they heard me start talking to you. But the same level of debate and discussion and check-in has not diminished at all since leaving our kids here, our 4th graders at the ACES program. Just as a refresher, we had an open middle challenge for our 3 groups here, with 3 digits divided by 1 digit, using only the digits 1 through 9 one time each. Come up with a division sentence that gives us the smallest quotient possible. Right now, we're going to check in with the groups to see what they came up with and to kind of talk about their conversations on where they started. So we're going to start off over here in the front. So ladies, we've had a chance to listen in on some of the conversation. It's been wonderful to see like the level of enthusiasm and engagement that you've had. What is a division sentence that you've come up with that has given you the smallest quotient so far?
123 divided by 5.
123 divided by 5. Let me go ahead and just make sure I get that down. So, how did you ultimately get around to 123 divided by 5?
We were just trying a lot of different strategies to trying to get to the smallest quotient. So then we ended up changing numbers, and that's how we got it.
So you started off with small numbers and kind of played around with where to put them to get up with something as small as possible. So that's what ultimately took you to 123 divided by 5. Because I see that you had 123 divided by 4, and when you brought 5 in, it got you to something smaller, right? That's really interesting, and I want to get back to that in a moment, okay? I want to jump in on this table over here and see what we came up with. So what was the division sentence that we came up with? Go ahead and tell us.
This strategy was Jaime's strategy, and he wanted us to follow this strategy.
Okay, so your division sentence is 134.
No, it was 123 divided by 9.
123 divided by 9. Okay, tell us a little bit about 123 divided by 9. How did you get to that realization?
It's because I thought the smallest number would, with the biggest dividend, would give it the smallest digit.
So you wanted to start off with the smallest possible divisor, and then you realize if I divide it by larger numbers, I'm going to have fewer in each group that I create from that. So I have to not just create the smallest starting number, but a large divisor as possible to create that quotient that I'm looking for. That's a really interesting approach. I want to jump back in here with our group here. What was the division sentence that this group came up with here?
126 divided by 3, but now I'm trying to find all the multiples of 126 divided by something, but it kind of backfired.
Well, no, I think what it ended up leading to was a strategy where you came to the realization that when you divide it by larger numbers, you get smaller quotients, right?
126 divided by
But
6
also,
equals 21.
you said that we can't use the same number
Yes.
in here or here, right?
So you can't use the same digit twice in the same division sentence.
Well, 126 divided by 6, that backfired on me. And
Right.
126 divided by 12 also backfired on me.
So you, in addition to seeking the smallest quotient, you wanted to seek the smallest whole number. You didn't want to have any remainders in seeking yours. I don't know if that was a part of it. I think that if you do have remainders, that still qualifies as a smaller number. So for example, we had a group come up with 123 divided by 9. Let's see, you guys came up with 126 divided by 9 and got 14? Okay, so let's check out 123 divided by 9.
What's the answer?
So very quickly, I wanted to jump in and share some of the results with the rest of the class. 126 divided by 9 for our back group, they discovered that that was about 14. When you did 120, have you calculated 123 divided by 5 to figure out what that is? Well, what did you get for that?
We got 24 remainder 3.
24 remainder 3. That's interesting. Remainder 3. Now, what we really mean by remainder 3 is that there's 3 left in that last group of 5, right? So another way to represent that is 24. Oh, you guys have the purple here. 24 with 3 out of the last 5, or 24 and 3/5, right? So let's look at 123 divided by 9. And I'm going to go ahead, forgive me, world, I'm going to use long division on this. 123 divided by 9. I have 9 into this 12 once. I'll subtract that for 3, bring a 3 down. 9 into 33. I know I can get to 27 with 3 times. And I'll have 6 remaining. So this ends up being 13 and 6/9. And I know I can simplify that to 13 and 2/3. However, with our group in the back that did 126 divided by 9, this might very well be the smallest whole number quotient, but 13 and 6/9 does end up being a third less than 14. So to our group here in the front with 123 divided by 9, congratulations, you've won our prizes. I also want to commend all of our groups to coming to an understanding about division. When you have larger divisors and smaller dividends, you end up with larger quotients. But when you have smaller divisors and larger dividends, you end up with even smaller quotients. So a really interesting exploration about how to play around with division using just 4 empty boxes. When we come back, I've got a little bit of the holiday sprinkle and magic I'm going to share with my group here while bringing in some multiplication and division understanding. Hey, thanks a lot. Welcome back to Panama School. We're here with this wonderful group of 4th graders. Very insightful, very engaged, very collaborative. And, you know, they were so helpful with each other. Then the conversation level was so rich that I figured I would recruit them with help with one of my tasks that I have around the holiday season. So every year, my family puts together a calendar for the days leading up to December 25th. 25 days of giving. 25 days, each day, an act of giving or kindness or thoughtfulness to help us reach out to help those around us in our community here locally and abroad. And these could be things like reaching out and contributing to a Teachers Donor Choose campaign, or it can be as straightforward and simple as giving random compliments to 5 people. It could be as forward-thinking as buying a cup of coffee for the person behind you in the drive-through line and seeing if they buy it for the person behind them and seeing how long it goes. So I built this calendar and didn't realize that I'd be here today. So I looked to see what my task was for today. And my task, I did this to myself, was to give holiday treats to 100 people. I may have a problem. I don't see 100 people in this room. However, I could think about ways to distribute 100 in a lot of different ways. And that's what I hope we can explore here today, looking at the number 100. This is a group that's been exploring multiplication and division. And it's always good to kind of go back and play around with how those numbers kind of come together. And 100 is a very powerful number to play around with. So I wanted to kind of brainstorm here. What's one way we could multiply and get to 100? I'm just going to throw that out there. One way to multiply to get to 100. Go for it.
20 times 5.
20 times 5. I can do 20 times 5. So I'm going to go ahead and represent this as people, and the second value is going to represent the pieces of candy they get. So I can find 20 people and give them 5 pieces each. That's one way I could do it. What I'd like you to do is come up with as many different combinations and ways I could get to 100 as possible.
Oh, that's easy.
Go ahead and write those down, and let's see how many we can come up with in 1 minute. Go for it.
Wait, just times 2.
Well, we can do the reverse. If you can represent it with division as well, that's wonderful. So you can say 100 divided by something equals something. You sure could represent it with addition. Absolutely. That's one. Can you come up with as many as possible in the next minute? Okay? Now here's what I'm going to do. I'm going to make this a group activity. When you come up with one, I would like for you to run up to the board, write it up there. Oh, they're going, everybody. Oh, Duck, get out of the way. Woo! It's Tarek. Maybe I could have been a little more tactful with that, but how often do you see kids running up to the board to write math expressions? I'm going to take that every single day. Now, we're seeing some duplicates here. Try to come up with ones that have not been put up on the board yet.
Hey, Charles, you copied mine. Yes, you did.
You shared thoughtful ideas, which means you both have excellent ideas together. Ideas don't get stolen, they get borrowed.
Excuse me. Do you get our homeworks back?
We're also seeing different representations of the same ideas using addition as well as a division. Repeated addition, also a very powerful and helpful way to make sense of multiplication. I could be very, very generous and say, you know, who's to say that everybody has to have a whole piece of candy? If I wanted to make more people happy, maybe I could take smaller pieces, right? So let's say, for example, I had a half a piece of candy per person. How many people would I have to give candy to in order to get rid of all of my 100 pieces? It would probably be like, well, let's think about it this way. 1 half. How many halves are in one whole piece? 2, right? 2, right? A half and a half is a whole. So I have 2 per piece, but I have 100 pieces. So how many half pieces of candy would I be able to give out?
50.
Well, that'd be if every person got 2. What if every person got 1 half?
200.
200, right? So I could do, I'm going to go ahead and throw that up here. 1 half times 200. Hey, if you wanted to do repeated addition, could you do a half plus a half plus a half plus a half 200 times? You could, but you'd be a fool because that would take forever. But math is powerful in that you can represent it so many ways. Now, there's a lot of ways that I'm going to have to consider passing this candy out. And they've made a lot of sense out of 100 and ways to distribute this, as well as ways to be kind of expressive. How would you start off with 500 and then take away 400 pieces of candy from 400 people? You want to tell that to those 400 people? That's up to you. But my hope with this activity is that we consider that generosity and giving can come in a lot of different forms. And so I want to thank everybody here at Panama School for their work today. And I want to be a man of my word and honor them and the spirit of the holidays on this, another 25th day of giving. Ladies and gentlemen, thank you so much for your work today.